So what exactly is this soil? Soil is the thin layer of loose mixture of small rock particles and rotting organic matter that covers much of the world's land surface. It supports all forests, grasslands, and crops from which all living creatures on Earth derive their food. Various forces of nature, such as changing temperature, running water, and wind, affect formation of soil. These forces of nature, along with the chemical and organic changes that take place in the soil, contribute to the evolution of soil. Thus, soil itself has evolved over millions of years. Constituents of soil. Soils are derived from parent rock material through a process of breakup or wear and tear. Decomposed vegetal and animal remains, referred to as humus, is an important constituent of soil and adds to the fertility of the soil. Besides humus, silica, clay, and sand are the other constituents of soil. Faulty agricultural practices, overgrazing, and deforestation lead to soil erosion. Improved agricultural practices, reduced pressure of grazing, and afforestation can help in the conservation of soils. Soil fertility. Soil fertility refers to the strength of the soil to support plant life. Fertile soil has the following characteristics. First, it contains adequate amount of moisture to supply essential nutrients to the plants. Second, it has sufficient depth to enable the plants to grow their roots as per their requirement. Third, it is rich in nutrients such as nitrogen, phosphorus, and potassium that are necessary for basic plant nourishment. Fourth, it contains organic matter that improves the structure of soil. Soil fertility can be improved by adding fertilizers to the soil to make up for the missing nutrients. Soil classification. According to its location, soil can be categorized as: first, residual or sedimentary soil. Almost all soils are formed in situ, that is, they are formed in their original position by the breaking up of parent rocks. They include black soil, red soil, laterite soil, desert soil, etc. Second, transported soil. These soils are transported by various agents of erosion and consist of sediments carried and deposited by rivers and winds. India is a vast region with varied natural environment. We find several physiographic regions and different types of climate. Therefore, a number of soil types have developed here. The soils of India are classified on the basis of their origin and formation as follows. 1. Alluvial soils. These soils are formed by the sediments brought down by rivers. They are also rich in chemical ingredients. The rivers deposit very fine particles of soil called alluvium in their plains during the course of their long journey. Alluvial soil is also known as riverine soil because it is mainly found in the river basins. It is a mixture of sand, clay, silt called loam. These have been deposited by three important river systems: the Indus, the Ganga, and the Brahmaputra. These soils occupy 40% of the land area. The entire northern plains are made up of these soils. These soils are also predominant in coastal plains and deltas, particularly in the deltas of the Mahanadi, the Godavari, the Krishna, and the Kaveri rivers. On the basis of its age, the alluvial soil is of types Bhangar and Khadar. The Bhangar, or older alluvium, is composed of lime nodules, kankar, and has a clayey composition. The Khadar is light in color and is composed of newer deposits. Khadar is more fertile than Bhangar soil as new layers are deposited year after year during monsoon floods. Crops can be grown on old alluvial soils by using manure. They form the largest and most important group as they contribute the largest share to the agricultural wealth of India. Distribution. First, inland alluvium. These soils are found on the plains of the Indus, the Ganga, and the Brahmaputra rivers, extending from Punjab and Sindh in Pakistan to Bangladesh and Assam in India. Punjab, Haryana, Uttarakhand, Uttar Pradesh, Bihar, West Bengal have alluvial soils. These soils also cover a part of Gujarat and a few patches in Rajasthan. Second, deltaic alluvium. The deltaic alluvium is found in the deltas of the Ganga, Brahmaputra, Mahanadi, Godavari, Krishna and Kaveri rivers. Third, coastal alluvium. It is of tidal origin. It is found in the coastal strips of peninsular India. It is also found in the plains of Gujarat. Characteristics of alluvial soil. First, it is formed by the deposition of the river load as it flows from its upper to its lower course. Second, in the upper reaches of the river valleys near the place of their origin, the soils are coarse. Soil particles are large and non-uniform. Such soils are predominant in Piedmont plains, that is, plains near the foot of the mountains. As we move further down a river valley, the soil particles become smaller and more uniform. They are found up to a depth of 500 meters. Third, the alluvial soil of the upper Ganga valley is dry, porous, sandy, faint yellow, and consists of clay and organic matter, while the soils of lower Ganga valley, that is of West Bengal and Bangladesh, are more compact, less coarse, and more moist. Fourth, it is light and porous, therefore easily tillable. Fifth, it is a fertile soil as it is rich in minerals, especially potash and lime. Sixth, it is deficient in nitrogen and humus, except the alluvium of the Ganga deltaic region, which is rich in humus. Seventh, it is suitable for the growth of a large variety of Rabi and Kharif crops. Eighth, soils in the drier areas are more alkaline. Crops. The soils are fertile and suitable for cultivation of rice, wheat, sugarcane, cotton, tobacco, gram, and oil seeds. In the lower Ganga Brahmaputra valley, they are useful for jute cultivation. Difference between Bhangar and Khadar soil. Old alluvium soils, known as Bhangar, occupy the largest part of northern plains, whereas the areas in northern plains that lie below flood levels is made up of Khadar. Bhangar is above the flood levels of rivers and presents a terrace-like structure, while Khadar is younger alluvium as flood waters deposit new layers every year. Bhangar is full of kankars, that is, lime nodules, while Khadar is formed of fine silt and clay. Bhangar is not very fertile, while Khadar is very fertile and ideal for intensive cultivation. 2. Black soil. This soil is black in color and is also known as the Regur soil or black cotton soil. It is dark in color and is suitable for cotton cultivation. The soil is the residual soil, that is, it is formed at the place of its origin over the underlying rocks. Since it is formed by the denudation of volcanic rocks, it is also known as lava soil. Distribution. The Regur soils are concentrated over the Deccan lava tract, which include parts of Maharashtra, Madhya Pradesh, Gujarat, Andhra Pradesh, Karnataka, Rajasthan, Uttar Pradesh, and some parts of Tamil Nadu. Characteristics of Regur, that is black soil. First, it is fine textured and clayey in nature. Second, it has high quantities of lime, iron, magnesium, and generally poor percentage of phosphorus, nitrogen, and organic matter. Third, it is black in color as it is formed from weathered lava rocks. Fourth, it is very clayey, means it has up to 50% clay content and therefore highly retentive of water. Because of high clay content, these soils expand when wet and become difficult to plough. During the dry season, the black soils shrink and develop big cracks which help in air circulation. Fifth, the soil is very fertile in most of the places. Sixth, it is suitable for cultivation of cotton, jowar, wheat, sugarcane, linseed, and gram. Seventh, in any season, it has moisture stored in its subsoil. Crops. Besides cotton cultivation, these fertile soils are suitable for growing cereals, oilseeds, citrus fruits and vegetables, tobacco, and sugarcane. The moisture retentiveness of black soil makes it suitable for dry farming. 3. Red soils. It is a category of soil which develops on old crystalline rocks. Under prolonged weathering by rainfall, ancient crystalline and metamorphic rocks of the peninsular plateau break up to form these soils. These soils differ from place to place on the basis of the parental rock material and climatic conditions. They are red in color as they contain large amounts of iron oxides. At several places, their color slightly changes as they appear brown or grey. They look yellow when they occur in a hydrated form. Distribution. Red soil forms the second largest soil group in India and is found mainly on the plateau region of peninsular India from Tamil Nadu in the south to Bundelkhand in the north and Rajmahal Hills in the east to Kutch in the west. Red soils cover almost the whole of Tamil Nadu, Karnataka, Andhra Pradesh, southeastern Maharashtra, parts of Odisha, Chhattisgarh, Jharkhand, Bundelkhand, Meghalaya, Mizoram, Manipur, Telangana, and Nagaland. Scattered patches of red soil are also found in Birbhum in West Bengal, Mirzapur, Jhansi, Banda, Hamirpur in Uttar Pradesh, Udaipur, Chittorgarh, Dungarpur, Banaswara and Bhilwara districts of Rajasthan. They practically encircle the entire black soil region on all sides. They extend southwards in the west, along the Konkan coast of Maharashtra. Characteristics of red soil. First, red soil has got its name from its color. Second, it is porous and has a high percentage of iron oxide. Third, it is generally shallow and its pH value ranges from 6.6 to 8. Fourth, it is loose and aerated. Fifth, it is poor in nitrogen, phosphorus, potassium, and organic matter. Sixth, it is ideal for dry farming as it is formed in poor rainfall areas. Seventh, it is not fertile but responds to fertilizers. Eighth, it needs irrigation support for cultivation. Ninth, it contains soluble salts in small quantities. Crops. Though red soils are suitable for cultivating almost all crop types, they are most suitable for growing vegetables, rice, ragi, and tobacco. Groundnut and potatoes can be grown on coarse soils at higher levels and sugarcane on heavy clays at lower levels. 4. Laterite soils. These soils are formed as a result of atmospheric weathering of rocks under conditions of high rainfall and temperature with alternate wet and dry periods. They are residual soils formed by leaching due to tropical rains. Well, leaching is the process in which the nutrients get percolated down below the soil due to heavy rainfall, thus leaving the topsoil infertile. This is also called desilication. Due to heavy rains, lime and silica are leached away and aluminium compounds are left behind. Humus content of the soil is removed by bacteria that survives well in high temperature. There are two types of laterite soil: upland laterites and lowland laterites. Upland laterites are formed over hills and upland. From there, they are transported by streams towards lowland. Such transported soils are known as lowland laterites. Distribution. These soils mainly occur in the highland areas of the peninsular plateau, especially on the summits of the Sahyadris, Eastern Ghats, Rajmahal Hills, and many other hills in the eastern parts of the peninsula. Patches of laterite soils are found in Madhya Pradesh, Odisha, Maharashtra, West Bengal, Andhra Pradesh, Telangana, Karnataka, Kerala, Tamil Nadu, and along the top slopes of the peninsular mountains, the western and eastern Ghats. Characteristics of laterite soil. First, it is of a coarse texture, soft and friable. Second, it is red due to the presence of iron oxide, which is formed by leaching. The soluble plant foods like potash are removed from the topsoil, leaving alumina and iron oxide. Third, it is a porous soil. Silica is removed from it by chemical action. It is poor in lime and magnesium and deficient in nitrogen. Fourth, it does not retain moisture and hence is not fertile. It suits only special crops like tapioca, cashew nuts, tea, coffee, etc. Fifth, it is acidic in nature as alkalis are leached. Sixth, it is considered suitable for building purposes. Crops. As the laterite soils have low fertility because of high acidity and low moisture retention, manuring and other activities are required to make them suitable for growing crops such as ragi, rice and sugarcane. Paddy is grown on lower elevations, whereas tea, cinchona, rubber and coffee are grown on higher elevations. Soils. Here's a table showing soils, their formation, areas where they are found, characteristics of the soil, and crops grown in the particular soil. So let's first see alluvial soil. It is formed by deposition of sediments by rivers. Inland alluvium is found in Punjab, Haryana, UP, Bihar, West Bengal, parts of Gujarat and Rajasthan. Deltaic alluvium in the deltas of Ganga, Brahmaputra, Mahanadi, Godavari, Krishna and Kaveri. Coastal alluvium is found along the coastal strips of the peninsula. Characteristics of alluvial soil. It is loamy, coarse and dry in upper reaches of the river and gets finer and moist as the river flows down. It is rich in minerals, especially potash and lime. It is poor in nitrogen and humus. Crops grown in alluvial soil are large variety of rabi and kharif crops, rice, wheat, sugarcane, cotton, gram and oilseeds, jute in Ganga-Brahmaputra delta. Next, let's have a look at black soil. It is residual soils formed by weathering of lava rocks. Areas where it can be found: Deccan Lava Tract, Maharashtra, Madhya Pradesh, Gujarat, Andhra Pradesh, Karnataka, Rajasthan, Uttar Pradesh and parts of Tamil Nadu. Its characteristics: it is clayey, black in color, rich in lime and magnesium, poor in phosphorus, nitrogen and organic matter. It is very fertile. Crops grown in black soil: cotton, cereals, oilseeds, citrus fruits and vegetables, tobacco and sugarcane. Next, let's see red soil. It is formed by prolonged weathering of crystalline rocks. Its formation differs on the basis of parent rock material and climatic conditions. Areas where we find red soil: Plateau region of peninsular India extending northwards along Konkan coast, Tamil Nadu, Karnataka, Andhra Pradesh, southeast Maharashtra, Chhattisgarh, parts of Odisha, Jharkhand, Bundelkhand, Meghalaya, Mizoram, Manipur, Telangana, and Nagaland. The soil is loamy or sandy, red in color due to large amounts of iron oxides. Deep and fertile in lowland, thin and poor in highlands. It is poor in nitrogen, phosphorus, potassium, and organic matter. Crops grown in red soil are vegetables, rice, ragi, tobacco, groundnut, and potatoes. Another kind of soil is laterite soil. It is formed due to leaching in areas of heavy rain. Laterite soil is found in highland areas of peninsular plateau, patches in Madhya Pradesh, Odisha, Maharashtra, West Bengal, Andhra Pradesh, Telangana, Karnataka, Kerala, and Tamil Nadu. It is coarse and porous, red due to iron oxide, poor in lime, nitrogen, and magnesium. It has high acidity and low moisture retention. Crops grown in it are tapioca and cashew nuts, and crops grown with manure are ragi, rice, sugarcane, tea, rubber, and coffee. Soil erosion. The removal of the topsoil cover by water, wind, and human activities is called soil erosion. Man is responsible for soil conditioning either through agriculture or through pollution like dumping chemical wastes in water bodies as well as underground. Besides human activity, soils are degraded by nature during drought or floods. 1. Soil erosion by water. First, sheet erosion. It occurs on gentle slopes and is the slow removal of a thin layer of soil when vegetation is destroyed. Rainwater washes away the thin layer of bare soils. Second, rill erosion. When sheet erosion continues for long, the silt-laden runoffs form many finger-shaped rills or grooves over a large area. This is called rill erosion. It is the intermediate stage between sheet erosion and gully erosion. Third, gully erosion. During heavy downpour, deep gullies are made on bare soils on account of water runoff. Gully erosion removes nutrients and heavy load of loose soils, making the soil unproductive. It makes water very muddy. This is seen in the Chambal Valley region. Fourth, leaching. After harvesting, farmers leave the soils bare for some time. During rainfall, the nutrients in the soil are leached or percolated below. Fifth, sea or shore erosion. The tidal waters of the sea cause considerable damage to the soil along the coast. The powerful waves dash against the coast and break hanging cliff rocks. The broken material is then removed by the retreating sea waves. This type of sea erosion is seen throughout the eastern and western coasts of India. Sixth, stream bank erosion. Streams and rivers change their courses by cutting one bank and depositing the silt loads on the other. During flash floods, the damage is accelerated. Stream bank erosion is prevalent in the floodplains of Ganga, Yamuna, and other rivers. As a result of stream bank erosion, large areas of agricultural land in the states of Uttar Pradesh, Madhya Pradesh, Rajasthan have been transformed into ravines. 2. Soil erosion due to human action. First, the annual rate of loss of forest cover in India is estimated at 47,500 hectares. This loss of vegetation cover leads to sheet erosion on hilly slopes because water, instead of sinking into the ground, washes the soil down. In the second stage, in the absence of vegetation cover and washing off of the absorbent topsoil, rills begin to appear on the landscape. In the third stage, the water runoff during heavy rains may develop deep grooves, causing gully erosion. Second, the outer Himalayas, that is the Shivaliks, the western and eastern Ghats, are subjected to deforestation by man. These areas also receive heavy monsoon rains. The removal of vegetation cover for different land use like railway lines, roads, buildings, or even agriculture has caused sheet, rill, and gully erosion. In these areas, local population practices shifting cultivation. The heavy rains then wash away the bare soil from the slopes to the valleys below. Third, another important cause of sheet, rill, and gully erosion is uncontrolled grazing of domestic animals in the valleys and the upper slopes. 3. Erosion by wind. Wind erosion refers to the movement and deposition of soil particles by wind. It occurs when soil devoid of vegetation is exposed to high-velocity wind. Wind moves soil particles 0.1 to 0.5 millimeter in size in bouncing or hopping fashion, and those greater than 0.5 millimeter by rolling. The former is known as saltation and the latter as soil creep. The particles less than 0.1 millimeter or the finest particles detach into suspension. In fact, wind erosion is most visible in the suspension stage as dust storms or subsequently as deposition along fence lines and across roads. Wind erosion reduces the productive capacity of soil as most of the nutrients required by the plants are carried away by the wind. Soil erosion in India. Causes of soil erosion. First, heavy population pressure on land. India's forest cover continues to be very low, just 22.4% of the total area. On the other hand, the population continues to rise at a rapid rate and has already crossed the 1 billion mark in the year 2000. More forests are being destroyed to house and feed the increasing population. The heavy pressure on land is the main cause of soil erosion. Second, nature of rainfall. India receives 80 to 90% of rainfall in the monsoon season. Heavy downpour during monsoon months causes floods. In the remaining months, droughts are frequent. This affects the soils. Third, overgrazing. The number of domestic animals, particularly the cattle in India, is the highest in the world. The cattle freely graze in open lands, making them bare of vegetation. Winds carry away dry soil particles from the bare landscapes. Thus, soil erosion takes place. In many parts of Rajasthan, excessive grazing by cattle has resulted in the exposure of the topsoil to elements of denudation. Fourth, bad farming techniques. The poor farmers plough fields in traditional ways. The farming techniques and small size of holdings lead to soil erosion on a large scale. The absence of terracing, contour cultivation, crop rotation, and the improper use of manure, etc., have caused serious problems of soil erosion. Fifth, topography. Northeastern parts of India, Shivaliks, and hilly regions in South India are affected by soil erosion because of steep slopes and heavy rainfall. During heavy rainfall, soils are washed away by running water down the slope. Sixth, deforestation. Forests are destroyed so that more land can be used for cultivation. Cutting off trees exposes the soil to water and wind, which leads to soil erosion. Regions of soil erosion. In India, the problem of soil erosion has attained a menacing proportion. In fact, soil erosion is one of the great enemies of Indian agriculture, responsible for low agricultural productivity. According to an estimate, every year, rainwater alone washes out 1/8 centimeter thick fertile topsoil. Among the states, Rajasthan comes on the top of the soil-eroded regions, followed by Madhya Pradesh, Maharashtra, Uttar Pradesh, Gujarat, Andhra Pradesh, and Karnataka. The worst affected areas include, first, the Badlands of the Chambal and Yamuna rivers. Second, the Piedmont zone of the Western Himalayas. Third, the Chota Nagpur Plateau region. Fourth, the Tapi Sabarmati Valley region in Gujarat. Fifth, the Regur soil area of Maharashtra. And sixth, the dry areas of Rajasthan, Gujarat, and Haryana. Following are some of the measures taken to prevent soil erosion and to conserve soils. 1. Terrace farming. On hilly slopes, terraces act as bunds and prevent the soil from being washed away by running water. Terrace farming is practiced with successful results in Japan, Southeast Asia, and the USA. 2. Shelter belts. Farmers plant trees in several rows to check wind erosion. They are known as windbreaks. 3. Contour ploughing. Ploughing along contours on a slope prevents soil being washed away by rainwater or by surface runoff. Contours act like bunds. Terraces are levelled into step-like small fields with even slope. Contour ploughing is common in Japan, China, and some Southeast Asian countries. 4. Strip cropping. Crops are grown in alternate strips of land to check the impact of the winds. 5. Construction of dams. Rivers cause soil erosion. Dams are built in the upper course of rivers to control the erosion of soil. 6. Plugging gullies. The gullies made in the soil are plugged with deposition of silt during heavy rains. 7. Planting trees. The trees, like in the case of shelter belts, are planted along the edges of the fields, the wasteland, and on steep slopes to prevent soil erosion as well as to enhance the capacity of the soil to retain water. Conservation of soil. There is an acute need to prevent soil erosion because of its adverse effects, which include the following. First, loss of fertile topsoil together with its mineral nutrients from the upper surface lead to gradual loss of soil fertility and agricultural productivity. Second, lowering of the underground water table and decreasing soil moisture. Third, drying of vegetation and extension of arid lands, increase in the frequency of droughts and floods. Fourth, silting of river and canal beds, recurrence of landslides, adverse effect on economic prosperity and cultural development. Vicious cycle of poverty and soil erosion. Vicious cycle of poverty and soil erosion are shown in given diagram. To counter this vicious cycle of poverty and soil erosion, government agencies need to encourage, first, use of technology for soil conservation. Second, use of high-yielding crop varieties. Third, alternative avenues of livelihood. Fourth, limit increase in population. Soil conservation schemes. In India, from the very first 5-year plan, soil conservation measures were launched with emphasis on development of technology for problem identification, formulation, and implementation of schemes. The programs under the state plan aim at conservation of soil mainly on agricultural lands, with some components of land reclamation, soil and land use survey, raising of utility trees on private and common lands. First, the centrally sponsored scheme of integrated watershed management in the catchment of flood-prone rivers was launched during the 6th plan in 8 flood-prone rivers of the Gangetic Basin, covering 7 states and 1 union territory. It aims at enhancing the ability of the catchment by absorbing larger quantity of rainwater, reducing erosion and consequent silt load in the stream and river beds, and thus helping to mitigate the fury of floods in the productive plains. Second, a scheme for reclamation and development of ravine areas was launched in 1987-88 in Madhya Pradesh, Uttar Pradesh, and Rajasthan. The components of this scheme included peripheral bunding to halt further ingress of ravines, afforestation of ravines for fuel, fodder, and reclamation of shallow ravines. Third, the Scheme for Control of Shifting Cultivation is being implemented since 1994-95 in the states of Arunachal Pradesh, Assam, Manipur, Meghalaya, Mizoram, Nagaland, and Tripura. The integrated program envisages settling of families practicing shifting cultivation. It helps them to practice terraced cultivation, raising of horticulture plantations, and afforestation to support animal husbandry and to meet fuel and fodder requirements. Fourth, National Project on Development and Use of Biofertilizers and National Project on Quality Control were implemented during the 7th five-year plan. These projects encouraged the use of biofertilizers as well as balanced and integrated use of fertilizers. Fifth, in urban areas, rainwater harvesting is a means of checking soil erosion besides recharging groundwater.